Hello everyone. So today we are going to start a topic from chapter 6, which is pump cavitation. So the cavitation, as we all know, is harmful for the machine, and so the cavitation is a phenomena that happens whenever in a flow line, whether it is a pump or any other turbo machine or just a pipeline, when the pressure goes below the saturation pressure, then there is a possibility that the vaporization of the liquid takes place, and when this vaporization takes place, then the cavitation happens. When the cavitation happens, that it has several effects. The bubble that forms during the vaporization process, because the liquid pressure has gone down to the saturation pressure, and the vaporization is taking place, so the small bubbles formation takes place, and those bubbles, they coalesce each other and make a larger bubble. And when this larger bubble experience higher pressure, when it goes down the line, whether it is a pipe or whether it is a pump, when it goes downstream and then experience slightly higher pressure, and then under that higher pressure the bubble collapse, and during that collapse of the bubble, it creates a lot of sound, and it creates a vibration, and it creates an impact on the surface of the machine. So due to that impact and due to that sound waves, a metal-like sound appears, like something is hitting the metal, and the impact of the collapse on the surface is that it erodes particles from the surface. So if this phenomena keeps happening, and this is a kind of a continuous process, then in the long run the metal deteriorates, so more and more particles from the metal surface erodes, and finally the surface is basically damaged. And this is how what you are seeing are the surfaces of the pump impeller, and these are the conditions after the cavitation erosion. So when we talk about the pump, so there are three, four phenomena that this creates a noise, it creates vibration, and it creates the stress on the surface of the impeller, and it creates erosion. So these are the outcomes or the result of a cavitation. So the cavitation, when we talk about the pump, the cavitation is we categorize this into two categories. The one is the suction side cavitation, and other is the discharge side cavitation. So the suction side cavitation is that whenever the pump takes the liquid from any supply line, for example, if you have a tank here, and then the line is connected, and then there is a pump connected with this, and the pump is supplying. So here, as we know that if at the water surface, free water surface, the pressure is atmospheric, and when it goes into the lines, then there is the losses, there is a friction loss, and there are minor losses. So at the inlet of the pump, the pressure goes down, and if the pressure drop is so much so that the pressure at this point goes below the saturation pressure, then the cavitation happens at the inlet of the pump, or we call it the at the suction side of the pump. So this is the reason that the pressure goes down, the saturation pressure at the suction side of the pump. So this happens when, so this creates so when the pressure goes down, the saturation pressure at the inlet of the pump, so this kind of the phenomena, we call it that the suction cavitation. So it may be due to the excessive pressure losses in the suction line, and it may be due to the so the one reason is that there are excessive pressure drop in the suction line. The other reason is that the pressure in the tank is very low. For example, the water level in the tank is not very high. It's like, because whatever is the rise or the water level rise in the tank, that basically contributes to the pressure here, right? If the water level is not very high, or for example that your pump is basically is taking the liquid from the tank, which is uh, which is basically at the below the pump level. So this is the pump level, this is the pump level, and this is the tank level. So the tank is below the pump level. So when the pump is sucking the water into the when sucking the water from the tank, then there is a lot of pressure loss here, as well as there is not enough pressure available in the tank. So which effectively makes that low pressure at the pump suction side. So that is the reason uh, the pressure at the suction of the pump goes below the saturation pressure and cavitation occurs. The second type of cavitation occurs in the pump is the discharge side cavitation. So the discharge side cavitation occurs when we have a pump and the pump is operating under very high pressure demand. For example, that you have a pump here, and your pump is connected after through some lines. It is connected to a tank, or let's say like this, right? So, and then it is supplying here. The water level in the tank is here. So, and then it is supplying the water to the tank. So when the pump is giving water, supplying water, and then it is filling up the tank. So over the time, then the tank water level will rise, and it will go to certain extent. So when it goes to a certain extent, that the exit pressure will increase. The pressure here will increase, and the pressure at the exit of the pump will also increase. That means that pump has to work more and more against this rise in the water level in the tank. So what happens, like if the situation is like that, when the pump is running and the pressure is increasing basically, so the pressure or the head developed by the pump is required more and more. So when the water level was rise, the pump might be producing, let's say, the 10-meter head, but when it goes up by 10 meter, then the pump has to produce, let's say, for example, 20 meter. So the pump has to work more and more, and the pressure in the pump is also will be more. So what happens that when the pump, as we see the structure of the pump, like this is the impeller of the pump, and the impeller has blades like this. So as the fluid goes out of the impeller, then because the pressure at the exit is higher, so the pressure inside the pump also gets higher because of this back pressure, higher back pressure. So the pressure in the pump also becomes higher. So when the pressure in the pump becomes higher, then what happens that I will show this to you through a diagram. So when the pressure goes higher in the pump, then what happens that here is the fluid where which is going into the pump at this point, and from here it is going into the pump, and then it is coming here, and then it is going out radially here. And when the pressure in the pump is very high, then what happens that at the exit of the impeller somewhere here, the pressure is also very high. When the pressure here is very high, then what happens, some of the fluid basically doesn't go out, and then it recirculates here. So some of the fluid, it doesn't go out, it recirculates here. So due to this recirculation, there is a possibility that due to recirculation there is a low pressure zone formation. So here the low pressure zone is formed at the exit, towards the exit of the impeller. And due to this low pressure, if this low pressure is so high that it reaches the saturation pressure, then the possibility that some of the liquid will vaporize here, and the vapor droplets formation will take place. And since the pressure is higher, little forward to this point, then this the bubble form will collapse, and the cavitation will happen. So due to the collapse of the blade, the vibration and the erosion of the impeller and the shock formation will take place. So this kind of cavitation is called the discharge cavitation or the discharge side cavitation. So as we saw that, so the cavitation you can categorize into two. The one is the suction side cavitation, and the other is the discharge side cavitation. So the discharge side cavitation usually occur towards the exit of the pump or towards the end of the impeller, whereas the suction side occurs towards the inlet of the impeller. So these two types of cavitations normally we have in the pump.